is how you want to construct your statistical test. So statistical test, we have, let's say we define set C. Set C is your rejection region. C prime is your acceptance region. Okay. Dia punya experimental value maksudnya sama, the same thing if I mention observation values, the same thing, experimental values or observation values. Okay. So if your observation values or your experimental values belong to your critical region, okay, belong to your critical region C, so we shall reject the null hypothesis. Otherwise, if this one belong to your C prime, which is your acceptance region, so you should accept your null hypothesis. At point C tu, we call this one as your critical value. For example, Z at alpha 0.05. So you compute your Z alpha. So it gives you 1.6449. So that is your critical value. Okay. Okay, we already compute example 3.1, 3.2 and also 3.3. Okay. Last class, I mentioned about 3.1 and 3.2, but in my video, I already add example 3.3. Okay. So this one, you want to find the power function of the test, and then you want to compute the powers at several parameters. Okay. So our null hypothesis is theta less than or equal 75, alternative theta greater than 75. Okay. Before this, you already learned your testing hypothesis. When we write theta less than or equals to 75, is the same thing if we write theta equals to 75. But if your theta is less than or equals to 75 in your null, that means in your alternative, it should be theta greater than. Okay, the same thing lah. Let's say if your null hypothesis theta greater than or equal, so that means in your alternative theta less than. But in terms of writing, we just write theta equal in your null hypothesis. That means we want to test theta equals lah. Okay. So given is your size sample n equals to 25. Theta is 75. Normal distribution, we have your mean theta, variance is 100. So that means your sigma square is equals to 100. Okay, sigma square is equals to 100. That means your standard deviation is equals to 10. So you want to compute the power function. So we have the observation x1, x2, x3, x25 greater than 25, 75. So I just change this one. So we have summation xi greater than 25, 75. So divide by 25 because we already know this is your sample size. So it changed to x bar. So this is your critical region or your rejection region. Okay. When we define C prime, so C prime is other than stated in your critical region. So this one in your critical region, x bar greater than. So that means your acceptance region is x bar less than or equals to 75. So K1 theta, probability rejecting H0. Okay. So this is your power function here, probability x bar greater than 75. Rejecting H0, this is your critical region. Yeah. So now we test at theta equals to 73, 75, 79 and also 77. Kita substitute. So since this is normal, so you use standard normal, change to Z. Okay. So standardized form, this is one. So substitute for each value, so we have the probability. Okay. So in this case, we have theta equals to 73, 0.1587, theta equals to 75, 0.5. And then theta equals to 77, 0.84. And then the last one, theta equals to 79 is almost 0.97. Okay. So then we proceed example 3.2, but different parameter, we use theta equals to 78. So the same approach, you repeat, you find theta equals to 73, 75, 77, 79. Okay. If we compare the second test, example 3.2, compare with the example 3.1. Okay, we refer to when your parameter is true. When your parameter is true, your null is theta equals to 75. So we look at this one, 75. So when theta equals to 75, the second test gives you the value 0.0668. So that's me rejecting H0. When H0 is true, it's just 0.07. Okay, small probability. Compare to the previous one, we have theta equals to 75. We have almost half. Rejecting H0 when H0 is true is half. So kalau boleh, that means we want to minimize the error. So this one is too large. So compare test 1 and test 2. So that means test 2 is more desirable compared to the first test. Okay, so that is it's just to compare. This example lead us to find the best critical region actually. Okay, so the next one, we repeat the same example. Okay, but this one, we want to find what is your N, what is your C. Given is your probability. Okay, probability 0.159, 0.841 when theta is equal to 77. So repeat the same process. Okay, so that means we standardize, we change to X bar. So X bar greater than C. So standardize, so Z greater than C minus theta over 10 over square root of N. The same as sigma. Sigma square is 100. Okay, so now you want to find N and C. Okay, so given the probability, you find what is your Z alpha. Okay, so this one 0.159. So you refer to your stats table. So Z greater than Z alpha is 0.9945. Okay, so you set up, you solve, you have the first equation. So second, we have the probability 0.841. Okay, 0.841, Z greater than. So it must be on your negative side, your left side. So since this one, your Z alpha must be negative value. Okay, because 0.84 is not provided in your stats table. So you use the concept 1 minus N. So 1 minus, we get the approximate value, which is 0.16. So, but your value for Z alpha is just negative because on the left side. So negative 0.9945. Solve, you have the second equation. Solve N and C, it gives you the value for N and also C. Okay, so again, this one you have a large sample size. Okay, so this one, when we have theta equals to 75, you have the probability rejecting H0 when H0 is true is 0.159, and then you have theta equals to 77. Okay, you have 0.841. Okay, again, theta equals to 77 is rejecting H0 when H0 is false. So that means kita reject H0 when H0 is false, we have the higher probability, which is 0.841 compared to the first test and second test. Okay, but in this case, when theta equals to 75, we only have a small probability. Still considerate probability, which is 0.16. Okay, but again, the price that we have to pay is we have to use a large sample size where we have to use N equals to 99. So this example show you that when we have a large sample size, the power of the test will be increasing. Okay, but again, all this testing is depend on the researcher, what you want to decide for your alpha and also beta. What you want for your type 1 error. You want the smallest as you want, ataupun kena considerate lah, kena balance. Okay, so again, we already show you the first example, second example and the third example. So this is the procedure how we want to find the best critical region which lead to the other section lah, which is certain best test. Okay, for today's punya lecture. Okay. Okay, so this one. So let's say tadi kita ada theta equals to 73, 79. Okay, theta equals to 73. When we have theta less than or equals to 75, so we have 0.0014. When we have theta equals to 79, we have the highest probability 0.9986. Again, this one yang theta equals to 73 is rejecting H0 when H0 is true. Because your H0 is true is theta less than or equals to 75. So you can use 75 or theta equals to 73. So small probability. So when theta greater than 75 in your alternative, rejecting H0 when H0 is false. When H0 is false, that means your H1 is true. We use theta equals to 79. We have the highest probability, which is 0.99. Okay, so again, but we have a large sample size to do the sampling. We need around 99 observations.